All right, so we've talked about structures in classes a few times. I wanted to actually hit the channel on them. These are known as abstract data types. An abstract data type specifies both the values that can be stored, what kind of data it holds, and operations that can be done on the values. And so hopefully the user of an abstract data type does not need to know the implementation of the data type, how the data is stored. So for example, when we use the file class, output file streams and input file streams, OF stream and IF stream, then we don't know how it works. We just know that it does work, and somebody can give us some instructions on how to use it, and we don't need to know the internals. And abstract data types are created by programmers, so we can create our own. So what is abstraction? A definition that captures the general characteristics without the details. So an abstract triangle is a three-sided polygon. Might be scalene, might be isosceles, might be equilateral. How it's represented in internal memory is, a mystery to us. We might store it as an angle, right, and in side links, or maybe we'll save it as a collection of 3 points in 2D space, or who knows, right? The person who's using our class may not know how we've stored it. They just need to know how to create an object of that type and how to use it. And so the data type defines the values that can be stored in the variable and the operations that can be performed on it. So combining data into structures. The general format is to use the word struct and give it a name. And then inside the angles, we list some data types. Let's get Visual Studio going. I'll make sure we're on anyways. Looks like we're on lecture UVW. Looks like I made an empty project and I actually wanted to make a console lab. I mean, an empty project would be fine. I just have to go and get the boilerplate out of it, right? So add new item. Been a while since I had to do this. Lecture w.cpp, go and grab the boilerplate. There we go. All right, so let's define a structure. Struct whole name, right? And a whole name consists of a first name, a middle name, and a last name. I guess we're in a world where we only have like 3 names, right? Not one of those people with 4 names or 5 names, 2 middle names or whatever. So first name, string middle name, string last name. Why are you underlined? Oh, because I put a colon there rather than a semicolon. So you give it a data type and then a field name, right? And so these are all these so-called fields in it. People call them different things. They can be called instance variables. They could be called members. They can be called fields. They can be called properties. Here they're calling them structure members. So let's run with that. Structure members. I'm going to add that as a comment here, right? These are the structure members, also known as instance variables, properties, fields, good enough, right? Different books call them different things. This book wanted to call them structure members. I'll probably call them members or instance variables, right? Because they are members of the class. Don't need this big output window. Let's shrink that down. So here's their structure. Got a student. He has a student ID. He has a name. He has a year in school, and he has a GPA. So you have to have a semicolon after the closing brace right here. See? Opening brace, closing brace. If you're using other programming languages like C# or Java, they omit that semicolon, but that's okay. We're using C++ and we can remember to put it there. Typically, people give their structure names in uppercase letters, just a common convention. Programmers who use Python, Java, C#, C++, lots of people do that. So make your class names and your structure names begin with an uppercase letter to distinguish them from variables. And multiple fields of the same type can be in a comma separated list. So if I'd wanted to, I could have just made this say string first name, comma, middle name, comma, last name. So the struct declaration does not allocate memory or create variables. We don't have any data yet that matches that structure, right? It's the template. It's the blueprint. Just because you buy a blueprint for a house doesn't mean that you own a house. You have to make the house. So you do that by using the data type, and then you give it a name. Well, that was a loud noise. What was that? Somebody join in? Nope. Don't know what that was. All righty. And one thing you can probably do, let me just test this, is you could put a variable name there, and then you could use that as a global variable if you so chose. Now, I would never do this in real life, but I'm just going to check to see if it works. And it does, right? My name dot first underscore name is equal to Fred. I'm not going to do it that way. I'm not going to create the variable as I define the structure. most programming languages don't support that. C++ does. So anyways, let's make some names, right? Whole name, me, comma, you. So me dot first name. I'll zoom in a little if I can. I don't know how to do it when I'm on the Mac. Nope. All right. Sorry. I hope that's large enough. So anyways, where were we? Me dot, oh, come on, stop it. Alrighty. Me dot first underscore name equals, you know, my name is Jeff. Me dot middle name is equal to, got a G as my middle initial, and me dot last underscore name equals quote Thompson. That's me. Well, how about you? You dot first name is equal to John. Or if you're a woman, you might call yourself Jane, or you can call yourself whatever you want, right? Anyways, let's go with John and you dot middle name is equal to Q, John Q, and you dot last name is equal to quote public. So you're John Q public and I'm Jeff G Thompson. And you can use this data type as a parameter for a function, right? So void say hello, and it's going to take a whole name. I'm just going to call it in. We're going to see out the message, hello, comma, end quote, less than in dot first underscore name. For some reason, it's wanting to put 2 underscores, comma, no, wait, no comma, followed by a space, followed by in dot middle name, followed by another space, followed by in dot last name, followed by ENDL, right? I really did want to zoom that in. Okay, it is zooming now. All righty. So after we've created our 2 names, right, we can print them out. I'm going to print out me, right? So I'm going to say underscore hello parentheses me. That'll call the function, passing in that variable. That argument's going to fill in that parameter variable. I'll do the same down here, right? Say hello to you. And if we're saying all this hello business, we can get rid of that see out, can't we? All right, so it's just a data type, just like int and double and, you know, and float and bool and all the other data types, except it's one that we created. Makes it an abstract data type. It's a structure. There's another abstract data type called class. Now, class is a structure that has methods attached to it. Technically, which are functions. Technically, you can attach functions to a structure as well, but typically people say that it's a class that has the functions attached to it. We'll see what the book says. So when I run it, there we go. It's going to say hello to me, and it's going to say hello to you. Launch the weather app. Did not mean to do that. All righty. So accessing structure members, you just saw how I do that. Use the dot operator, right? Student1.name, me.firstname, me.middle name, me.last name. Member variables can be used in any manner appropriate for their data type. Now, one thing we need to know is that you don't always use dots. If it's declared as a pointer, then you do another symbol. So if I made a pointer to you, right? So this is a whole name pointer. I'm going to call it P me because it's a pointer to me is equal to the address of the me variable, right? And whole name asterisk PU, which sounds funny, is equal to the ampersand of use. Now, if I want to change your last name from public to something else, private, you're no longer so public, then we would do PU, and then instead of the dot, we would do that symbol, the dash followed by the greater than angle. And then we can change our last name to private, right? And that's silly. Let's change it as, I don't know. Yeah, why not? John Quincy Adams. We're going to change your name to Adams. There we go. And we're going to change my first name to something. P me hyphen greater than first underscore name is equal to Jeffrey. Yeah, my parents are strange and they swap the position of the R and the E that some people have. All right, so there we go. And then we can print our names out again, right? Say underscore hello. Now I'm going to send this by its pointer rather than by the variable. I could just type me, but I'm going to be unnecessarily difficult and use the pointer. Well, if I'm using a pointer, I have to pass it in as an object, and so I need to dereference it with the asterisk, right? And then I can say hello to you doing the same thing, asterisk PU. If you have a pointer and you want to convert it back to an object to be usable, you have to dereference it so that you're no longer looking at the address. You're looking at the actual object that the address points to, so you just put an asterisk in front of it, which means that these things could have been changed like this. asterisk p me dot first name or middle name. Let's put my whole name there. No longer just G, it's a middle name, right? There we go. All right, why so many different ways of referencing it? I don't know. In the Java programming language, they don't support doing, hey, and that didn't work anyways. Maybe if I put that inside parentheses. Now that's horrible syntax, right? We would not want to do that. We'd either just want to do me dot middle name, or at most p me hyphen greater than middle name. So I'm going to delete that one. That one looks a little bit too much. Just as a reminder, if we want to pass things in by the fastest way possible, we could define this as a const reference. We could say that's a const and it's a reference, meaning we're not passing in a copy of the data, we're passing in the original data. But it's safe to do so since we're marking it as a const, right? If I try to change it, change my middle name to Bob, it's going to be a syntax error because this is defined as a constant. So we can't change any of the elements in it. So that'll run a couple of nanoseconds faster because it's not copying the object's data into here. It's just copying a reference, right? Pointing the original object to it. And in this particular language, you don't have to change anything about how you call it when you do that, right? I did not have to change that call, did not have to change that call. It worked just the same. So displaying a struct variable. If you just try to print the object to the screen with less than, it's not going to work, right? If I come up here and do cout, guess I have it running. Doesn't seem like it. All right, so if I do cout less than me, less than ENDL, we're not going to like the results. It's not even going to give us an error message. Well, maybe if I compile it, we'll see the error message. There are build errors. Let's go look at our error list. Can I expand the error list, please? Window error list. View error list. Please get larger. There. All right. So no operator less than matches these arguments. So it's not displaying it, right? We would have to display the individual components. We could print me dot first name, followed by a space, followed by me dot last name, last underscore name, less than end, right? And it's displaying that as an error for some reason, but I'm assuming that if I run it, it'll fix that. No, what have I done wrong? Oh, ENDL, excuse me. Is that gonna make you go away? Surely will. Okay, good. What if I wanted it to support that? I really would like to be able to print me out that way, or you out that way. We're gonna have to do what's known as creating an operator override. We really wanna support less than. And for this, I'm gonna actually have to Google it. Operator override less than. So overloading the less than operator for your own classes. And so we have to create an operator called oStream. And then we have to use the word operator less than. And then we use a reference to the output stream. And then the data that we want to pass in, which in our case is not going to be a date, but it's going to be a name. Well, I'm going to copy that because it's a good little template, right? So I'm going to come up here to my structure, and I'm going to change it, of course, to match what we really have. we don't have a date. This is a whole underscore name. And it's part of the class, part of the structure. Too many parameters for this operator. I wonder if I can get away with just removing that. Looks that way. Okay. So we're saying, hey, we want to be able to support less than less than. And when that happens, we want to print out their first name, right? So first underscore name, followed by less than, space, followed by last underscore name, followed by a space, followed by an ENDL. Or no, we don't even want to put an ENDL, right? Because we don't want that to happen automatically. There we go, right? Now, I don't know why this example used single quotes other than double quotes there. Both would work just as well. So what is this doing? When we try to print our object with less than, the compiler hooks it up so that the output stream gets passed in as a parameter so that we can send data to it. Let's go give it a shot. I would expect this error to go away now. Can't say that it did. All right, I'm not going to struggle too much with this if I can't get it to work, but I really wanted it to. It's too bad. No operator found, which takes a right-hand operand of type whole name. So we really did need that. Const whole name reference name or object or something like that. And it's giving me grief about it. See if I can pause the recording, figure it out, and then I'm going to stop struggling with it. All righty, I know what I need to do. I forgot that this method actually has to be declared outside of the class. And so here we're going to define it. It's going to be a output stream. If we felt like it, we could put the std : in front of it. Some of the examples do. And then we need to call it operator less than. And inside it, it's going to take an O stream as its parameter. And then it's going to take an object of our type as a parameter. So whole underscore, wait, whole, it didn't have an underscore in it. Whole name, ampersand, and let's make this one a const. I believe that'll work. Let me go and look at my example here. Yeah, I wanted it to be a const, okay, because it's not going to change it, is it? Const. And I'm just going to call it obj for object. And now we can see it out, right? See out. You know what? We've already done this thing several times. And it won't take that too long to type it in again, except it's not see out. We need to be sending it to that output stream. So OS less than obj dot first underscore name, followed by a space, followed by obj dot middle name, followed by a space, followed by obj dot last name, followed by, that's it. We don't need to do that. Okay, so there we go. So I could come down here, and now we can print you out just as easily as we could print out anything else, right? So if we wanted to say, I am so glad to meet you, comma, end quote, followed by you, followed by ENDL, and it'll print that out. I could do the same thing for me, right? See out, hi, I am, followed by me, followed by ENDL. And since I overrode the operator to support the less than operation, this will work. Or no, it won't. Operator less than must return a value. Okay, I think it's just supposed to return OS. No, it's not. Then what's it supposed to return? We saw it work. Did we not? I forgot to declare this with an ampersand because it's supposed to return the original object and not a copy of it. Oh, and now that's causing that grief. Well, this is annoying. Standard, : O stream, ampersand, operator, less than. Oh, now it went away. Good. All right, looks like all the errors have gone away just by benefit of waiting. Okay, and so, hi, I'm Jeffrey G. Thompson. I am so glad to meet you, John Q. Adams. All right, I'm going to pause the recording here. And we'll pick back up on this in a little bit.